Hi, I'm Tom Hill, and today I'm here to talk about using Artix-7 FPGAs for DSP applications. Being part of our 7 Series FPGA family, Artix-7 FPGAs are built on our shared, scalable 28 nanometer architecture that delivers the lowest cost and power for high volume applications. This makes them an ideal choice for DSP applications that place the highest emphasis on both cost and power. But that being said, the Artix-7 FPGA device families still deliver impressive levels of DSP performance and bandwidth. There's up to 1,040 DSP-48 E1 slices available on the largest device, the 350T, and this can deliver over 1,300 gigamax of DSP processing bandwidth. And Artix-7 devices also support up to 16 lanes of JESD 204B that support up to 106 gigabits per second of serial bandwidth for high-speed analog interfaces. The Artix-7 FPGAs share the same advanced DSP-48 E1 slice as the Kintex-7 and Vertex-7 FPGAs. These slices in the Artix-7 device can be clocked up to 638 megahertz and allow independent access to both the pre-adder and the accumulator for each multiplier. This slice also contains an 18 by 25 multiplier that helps deliver more efficient implementations for algorithms such as FFTs and include a pattern matching block that supports implementation of rounding modes that are typical in wireless and aerospace and defense applications. Also, keep in mind that Artix-7 devices share a scalable optimized architecture with both Vertex-7 and Kintex-7 FPGAs, allowing designs to be easily migrated between device families if higher performance is needed. The reference design we're going to show demonstrates the performance of Artix-7 FPGAs for DSP. What we are going to show here is a common DSP application, which is a digital up converter constructed using Xilinx DSP IP cores, including the FIR compiler, the DDS compiler, and the complex multiplier. Here we have a design that we have created using Simulink, using System Generator, and the Xilinx DSP block set. I can simulate the design to ensure functionally correct behavior. This is a digital up converter looped back into a digital down converter designed to the LTE WCDMA specification for 3G wireless. This design takes data from the analog interface and down converts the sampling rate to the baseband frequency. The DDC filter chain performs anti-aliasing and pulse shaping on the input signal. From the plots here, we can see that the power spectral density response is centered around 12 megahertz. I'm now going to show you how we set the performance constraints in System Generator. I've got the clock period set to 2.3 nanoseconds, and that equates to 368 megahertz. This will force a 3x oversampling of the 122.88 megahertz UMTS standard related to the baseband chip rate of 3.84 megachips per second. This additional level of overclocking allows DSP designs for wireless applications to be implemented on Artix-7 devices with fewer dedicated DSP hardware resources than competing high-volume FPGAs. Given these constraints, System Generator will automatically configure the filters to generate a hardware architecture that supports this overclocking structure. Here I'm using the System Generator user interface to build and implement this design to the 368 megahertz constraint. System Generator is now creating the hardware design and running it through implementation using the Xilinx implementation tools run in the background. This design is finished, and we can now view the timing report to see that the timing has completed with no timing errors. Also, a quick glance at the area reports shows that the 3x overclocking has allowed this entire design to be implemented with just 12 DSP-48 E1 slices. We've just shown how Artix-7 FPGAs offer a hardware solution for high-performance DSP that supports wireless designs clocking at 368 megahertz and allows overclocking of the DSP-48 E1 slice, resulting in more efficient hardware implementations. You can start designing today using the latest design software from Xilinx. Contact your Xilinx salesperson for availability of the Artix-7 devices. And to learn more about Artix-7 FPGAs, please visit xilinx.com.